Hello, Math Maniacs. This is Mrs. Long, and I already scrolled through half these slides. All right, today we are working on Unit 7. We're diving into a new unit, more math models, and this is similar to what we did at the end of last semester. Today we're going to be covering 7.01 and 7.02. Your assignment for today will be the 7.02 quiz, but by the time you watch this video, you're going to be such an expert, it'll seem easy. All right, there's Champ the Owl, because we are all champions here at GCA. I like that. I think that's pretty cool. Vision and mission, there's your code of conduct, peer tutoring, instructional lab. Our calendar is going to be a little different than this. I borrowed this PowerPoint from one of our other teachers. So our schedule's a little different, but I'll post that in the announcements for you. All right, your goals for this lesson. You'll be able to convert a percent to a decimal. Woohoo, check. Most of you can already do that. We'll review that though. Write a fraction in lowest terms. Again, I think most of you can do that. We have used both of those skills quite a bit this semester. And identify a transformation. This one might be, you probably could do this at one time, but you may need a little review. So we're going to take care of that today. All right, so let's look at our first objective here, and that's to be able to convert a percent to a decimal. And again, we've had to do this quite a bit this semester, and we looked at a couple different ways to do this. First, one way we looked at was if we had 58%, I could take the decimal here and move it 2 places to the left to get the decimal value. Okay, so 58% would be the same as 0.58. All right, another way to do it is to take 58, and we know that percents are parts of 100. That's what percent means, parts of 100. So I could turn it into the fraction 58 over 100. And then I could divide, and guess what? I get the same thing, 0.58. When you divide by 100, what it does is it moves the decimal 2 places to the left. So whichever way is easier for you to remember and do, go for it. Now, what they did here is they just said 58 divided by 100. We wrote it as 58 over 100. Okay? Now, let's look at our second example over here, 3.7%. 3.7%. So again, if I move the decimal 2 places to the left, bada bing, bada boom, it becomes 0.037. Okay? Or I could do the same thing. I could do 3.7% divided by 100, and I get the same thing, 0.037. Now, you also know that if I put a 0 in front of that, 0.037, that means the same thing. A lot of times people will write that 0 in front of the decimal so the decimal doesn't get lost and forgotten. Okay, so I think you guys can handle that. All right, simplifying fractions. Now, this is one that you probably learned a long time ago, but we need to take a look at here. If I have 6 over 21, my job to simplify this fraction or to get it to its lowest terms, my job is to figure out, is there anything that goes into both 6 and 21? We want the greatest common factor. What's the biggest number that would go into both 6 and 21? Well, I happen to know that 3 goes into 6, and I know that 3 goes into 21. So I'm going to do divided by 3 over divided by 3. 6 divided by 3 is 2. 21 divided by 3 is 7. So now I've written that fraction in its simplest form. Okay? Let's look at this one, 5 over 15. And something cool here is a lot of times I can look and I can say, does 5 go into 15? Like here I could have said, does 6 go into 21? Nope, 6 didn't go into 21. But when I come over here, 5 does go into 15. So 5 is going to be my greatest common factor. So I'm going to do divided by 5, divided by 5. 5 divided by 5 is 1, and 15 divided by 5 is 3. So those are equivalent fractions. That's how I simplify that fraction. All right, now Let's talk about transformations. A transformation is a change in a figure's position, shape, or size. Now, I know this seems like it's completely not related, but you'll see how it all ties back together as we go into the rest of the unit here. A translation is a slide, okay? A translation is a slide. A reflection is a flip. A rotation is a turn. So we've got a slide, flip, and turn. And then a glide is a slide and a flip. Okay? Slide and flip. So let's look at that real quick. We're talking about geometric figures now, and we're talking about how we can move them. Okay, now keep in mind that none of these involve a change in size. These are all just a change in position. Oh my goodness, that's tiny, isn't it? All right, so we're going to make our own slide for this. Let's see here. Let's do a slide, a flip, and a turn. All right, you ready? This is a translation. Sorry, that was too small for me to see. So if I have a square here, and that translation is a fancy word for slide. All right, so let's say I've got a square. Okay. And all I want to do is I want to move that slide over here to the right. I want to move that square over here to the right. So we're going to pretend like that square is congruent. If I slide this guy over, let me change colors for just a sec. If I slide him over, that is a slide or a translation. Or if I slid him down, there's a number of ways that I could slide him. I could slide him this way even, okay? All right, so then we have let's go with flip. All right, so then we have a reflection, which is a flip. All right, so let's say I've got this figure here, and I'm just going to sketch one for you. All right, and I want to reflect it or flip it over this line here. It's going to be just like a mirror image. I'm going to bring this guy over like this, and we're going to pretend that these guys are congruent, okay? But it just flips it over there, all right? All right, then we've got a rotation, which sometimes you might have heard called a turn. All right, so let's say I've got this figure here, and let me see if I can pull out another color for us. Let's say I've got this figure here. It's an arrow, okay? All right, now let's say we're going to rotate that guy. Zoop. And now he looks like this. All right, now remember, for real, these wouldn't be exactly the same, just in a different position, okay? So don't hold it against me that my drawings aren't perfect. All right, now the last one is a glide, and a glide is one you might not be familiar with. It's a translation and a reflection, okay? A translation and a reflection. So a glide is a translation and reflection. Okie dokie. So let's say I've got this figure here. Let's say I've got the letter P. Okay, so what I'm going to do is I'm going to translate him. So first I'm going to slide him over. I'm going to go whoop, and now he's here. All right, and now I'm going to reflect him. Let's say I reflect him over this line here. So what I've done is gone from this upright P, I've slid it over and flipped it upside down. Now it looks like a B. Okay, so that's the difference between all those terms. That's a good reference point for you. All right, now what I want us to do is go through the checkpoint and make sure you know how to do this. All right, so this might be a good time for you to pause me and practice these on your own before I give you the answers, okay? All right, so I see that you're back with me now. So what I'm going to do is I'm going to go ahead and solve these. 125%, remember I moved that decimal 2 places to the left. So I get 1.25 if I were to write that as a decimal. Okay, ba-ding, ba-ding, ba-ding. All right, 2 places to the left for 18% gives me 0.18. Now, these are the kinds that are kind of confusing because you have to add some zeros in. So if I'm here and I go ba-dink, ba-dink, I got to put a 0 in there. So I'm actually going to write that as 0.07. Okay, 7 out of 100 gives me 0.07. All right, so that's your first objective, being able to convert percents to decimals. All right, your next one was to be able to simplify fractions. And again, I'm going to let you pause me for a minute so you can try these on your own. All right, so I see you're back now, so we're going to give these a try. 6 out of 60. Well, again, I look at it and I say, does 6 go into 60? It sure does. So that's going to be the greatest common factor. So I'm going to divide the top and the bottom by 6. And I get 1 over 10 because 6 divided by 6 is 1. 60 divided by 6 is 10. Here, 4 won't go into 14, but what will? I think I could divide both of those by 2. 4 divided by 2 is 2. 14 divided by 2 is 7. Now, they don't have any more common factors, so that is my simplified fraction. Here, 15 won't go into 20, but 5 will. 5 will go into both of them, so I'm going to do 15 divided by 5, 20 divided by 5, and I get 3. 15 divided by 5 is 3. 20 divided by 5 is 4. So that's how you simplify fractions. Not bad, eh? All right, let's identify these translations. All right, here, what have I done in this very first one here? We'll call this number 1. What happened to the blue triangle to get the pink triangle? That's right, it was reflected across this line right here. So that one is a reflection. All right, what about this guy here? You know what? This is a reflection also. They reflected it right across this line. All right, I'm feeling good so far. This guy, they just slid him down. A slide is a translation. All right, this guy over here, they just rotated him around a little bit. Now, let's see what's happening up here. Up here, to me, it looks like they took this pink one and they slid it over here. And then, no, that's not what they did. What did they do? All right, here's what they did. They slid it down here. Oh, I am so out of time. This video only lets me have 15 minutes. And I'm at 13 and a half. So they slid it down here, and then they flipped it across this line. So that's going to be a glide because it's a slide and a flip. All right, this guy, they rotated. All right, now I'm going to stop this video. I'm going to make a second quick video to go with some practice problems, okay, so that you guys can try those on your own and then check your answers. All righty, I will see you in video number 2 in just a second.